So this is a list of all the problems that we're going to go through in this video. I suggest pausing the video here so then you can try these on your own and then playing them forward. So I'm just going to give you an opportunity to pause the video. So looking at our first one, just a reminder, they always start out the same. We put our premises here on the left-hand side of the tree, and then we put our conclusion on the right-hand side. So every single truth tree starts out the same. Premises on the left-hand side, conclusion on the right-hand side. So I'm going to just go in order with our premises and then conclusion. Here we've only got one premise, so I'm just going to break this down. As you can see, I color-coded the different statements. So everything that's in purple will be related to this premise here, and everything that's in orange will be related to the conclusion over here. So the first thing we have to do with our tilde P and Q is flip it across to get rid of that tilde. So once we flip this across, we get rid of the tilde. Now it's just regular P and Q. And if you look at our rules, if a conjunction is on the right-hand side, then that means either side is false. So either P is false, remember right side means false, left side means true, left side means true, right side means false. So either P is false or Q is false. And once we get to the individual letters, we're done with that statement, and now we're moving on to our next statement, which is our conclusion. And everything that we do for the conclusion has to happen in this branch and this branch. So what I'm going to do in this video is every time that I'm breaking something down, in each of the branches, they're going to pop up at the same time, just to drive home the point that all you're doing is just duplicating the work on each of these branches. So looking at our conclusion, the main operator in our conclusion is the wedge. It's holding together our tilde P and our tilde Q. So for a wedge, if it's false, if it's on the right-hand side, then we're going to stack these, because for a disjunction to be false, both sides have to be false. So that's why we stack them. So tilde P, tilde Q, tilde P, tilde Q. And then the last thing we really have to do is just flip these over. So we got to flip the tilde P over into a regular P, and we have to flip the Q over into a regular Q. So we just did the same thing 2 times over. Now we got to check for validity. We're going to look for instances in which we have a letter on both sides of our branches. So something on the left side, something on the right side that matches. Looking at our first branch here, we've got P's on both the left and the right, so that one will close. And then if we look over here, oh, we've got a Q on both sides of our branches, so that one will also close. So if all the branches close, that makes it valid. Okay, moving on to our second one. One premise again, and our conclusion. So premise on the left, conclusion on the right. I'm going to do this premise first. So everything in purple, that will be our first premise. The main operator for this statement is the ampersand. So we're just going to stack these, because where is a conjunction true? Well, it's true where both sides are true. So we just continue on our same branch. And then we just need to flip this tilde P over into a regular P, and then we're done with that first premise. Now looking at the conclusion, the main operator here is our arrow. So for an arrow to be false, because it's on the right-hand side, means that the left side is true, or the antecedent is true, and the consequent, or the right side, is false. So it's another stacking rule. We put our antecedent, or our left side, on the left side of the branch. We take our consequent, or our right side of the arrow, and put it on the right side of the branch. And then all we have to do is just flip this tilde Q over into a regular Q, and then we're done. No branching here, so don't feel like you always have to branch. Just follow the rules based on where the operator is. If the operator is on the left-hand side, right-hand side, sometimes it can just be a straight down truth tree. Now we just need to look for any instances in which we have a contradiction. Oh, look, we've got a P on the left side and the right side there. So the tree closes, and that also makes this one valid. Okay, now we've got 2 premises. So we've got this premise here and this premise here, and then our conclusion down here. So again, I color coded these. Everything in purple will be related to this first premise. Everything in green will be related to this premise, and everything in orange will be related to the conclusion. So I'm going to start with the first premise. Since it's got a tilde on the outside of its parentheses, it needs to get flipped over. So this will become P wedge Q, and we drop the tilde by flipping it over the tree. Then where is a wedge statement false because it's on the right hand side? Well, it's false where both sides are false, so we're just going to stack our P and Q, and then we're done with that premise. So we can move on to our next one, this tilde Q arrow R. So if an arrow's on the left hand side, so if a conditional statement is true, that means either the left side is false or the right side is true. So that's why the tilde Q is on the right hand side here. So right hand side's false, left hand side's true. So tilde Q on the right, R on the left. And then we just need to flip this tilde Q across to get rid of that tilde, and then we're done with that premise. Now looking at our conclusion, main operator again is the ampersand. It's holding together both of these tilde, this tilde P and this tilde R. So we have to do the ampersand first. Where's an ampersand false? Well, it's false where either side is false. So that means that we're going to have to branch off again, and it's going to be wherever the tilde P and the tilde R are false. So that's why we've got one on the right hand side here, one on the right hand side here. And then again, this is just the same exact thing happening on both of our branches. Then we just need to flip our P's over to get rid of the tildes, and then we just need to flip our R's over to get rid of the tildes on them. And then let's look up the tree. Well, I've got a Q on the left-hand side, Q on the right-hand side up here, and actually this is going to close off both of these branches at the same time because both of these branches go back up this way. So you're going to have a case in which you have a contradiction for both of them. Really, you could stop this branch here if you wanted to, if you saw that there's a contradiction, but my suggestion is just play it out and see what happens, and then that way you know if you don't make a mistake. That's the key. So now looking at this branch, I see a P on the left hand side, a P on the right hand side there, so that one will close. And then I see an R on the left hand side, R on the left hand side. I don't see anything there, so that one's going to be open. And since you have an open branch, it's going to be invalid, and you're going to need a counterexample. So we're going to get our counterexample by just going back up the tree this way, and we're going to look for which side each of the letters are on. So my P is going to be up here, so that's going to be false because it's on the right hand side. My Q is also on the right hand side, so that's going to be false as well. And then my Q is, my R is on the left hand side in both of these cases, so that's going to make it true. And so that's where we get our counterexample from. Okay, just have the one premise this time and then the conclusion here. So we're going to work on this first premise. The main operator in this premise is this wedge here. So where is a wedge true? Well, it's where either of the disjuncts or either of the sides are true. So that's why we're going to take the tilde P, put it on the left-hand side of one of these branches, and then take our Q arrow P and put it on the left side of this branch as well, because it's just signifying that one of them has to be true for this statement to be true. Okay, now let's just go ahead and flip this tilde P over to regular P, and we're done there. We still need to break down this Q arrow P some more. So where is where is an arrow true because it's on the left-hand side? Well, it's where either the left side or the antecedent's false, so that's why it goes on the right side here, or the consequent or the right side is true, so that's why the P goes over here. So Q on the right, P on the left, right? Then that premise is done. The last thing we have to do is just flip our Q across to get rid of our tilde. So that's why we just write the Q on the left-hand side for all of these. You could have flipped the Q up earlier if you wanted to. It doesn't really matter. Again, I just suggest going in order of the premises and then the conclusion, just to make sure you don't lose track of anything. Okay, so looking for contradictions, I don't see one here in this first branch. Looking here, oh, I've got one right there. I've got a Q on both sides, so that one's going to close. and I don't see a contradiction there. So here, this is going to be invalid, and then we're going to just pick one of our branches to get our counterexample. So P is on the right-hand side, so that makes P false, and Q is on the left-hand side, so that makes Q true. But if you notice, we have another open branch here. All you need to do is list one counterexample, but in this case, we could give we could give a different one than the one that we just gave. We could give it as P is true, or Q as true, because it's up in this branch here. Okay, here we've got two different premises, so that's why we got these two on the left, and then we got a conclusion on the right. So everything in purple, that's what we're going to start with first. Since the tilde is on the outside of these parentheses, it's the main operator, so it needs to get flipped over the tree to get rid of that tilde. Then if you have an arrow on the right hand side, remember that an arrow is false, which that's what the right hand side stands for, where P is true and Q is false, so that's why P is on the left, Q is on the right. Then that one's done. Then we just need to flip this second premise over to get rid of its negation here. So now we have the conjunction as our main operator, and if a conjunction is on the right hand side, that means it's false. So where's a conjunction false? Where either side is false, so we need to branch off. We'll write the P on the right hand side of one branch, we'll write the tilde Q on the right hand side of one branch, because the right hand side means false, left hand side means true. I'll keep saying it to hopefully make it sink in. And then we just need to flip our tilde Q across to get rid of that tilde, and then we're done. We're done with that premise, and our conclusion is just a single letter, so we don't really need to do anything else. Now we're just going to look for contradictions, and I see a P on the right hand side and a P on the left hand side, so that will close off this branch. And then looking at this one, I got a Q on the left hand side, Q on the right hand side in multiple places, so that one will also close off, which makes this valid. Okay, for this one we have a rather long premise here, which is going to make this really branchy, so please don't get scared by that. We're going to start with our premise here, and since it's a wedge statement, we need to break it down into these two branches in which the left side's true or the right side's true. So that's why we have our P arrow tilde Q here, and then our tilde Q arrow P here. Now we need to do these individual conditional statements. So where's a conditional true? Well, it's where either the left side is false or the right side is true. So that's why the P is on the right, tilde Q is on the left. And then we need to flip the tilde Q into just a regular Q, and then we're done with this part of the truth tree. For that premise, we need to come back over here and do this conditional statement as well. So again, conditional on the left hand side, so a conditional is true where the left side is false or the right side is true, and then we just need to flip this tilde Q over into regular Q, and then we're done with that premise. Now we need to take our conclusion and break it down in each of these branches. So again, this is going to look like a lot, but it's just repeating our steps. So where is a biconditional false because it's on the right hand side? Well, it's where the two sides don't match. So that's why I have a tilde Q on one side and P on the other, and then they're flipped on the other branch. And it's the same thing for all of these. I just need to now flip the tildes across those branches, so that's why this tilde Q becomes a regular Q, this tilde Q becomes a regular Q, and then you just repeat for all of these other branches. And then you're done. You just need to figure out if it's valid or invalid. Looking at this first branch here, it's ultimately going to be open. I don't see anything that's on the right hand side and left hand side. This next branch, well, I have a P on the left hand side and the P on the right hand side, so that one will close. And then looking at this next one over here, this one's going to be open as well. And then here I've got a Q on both sides, so that one will close. Looking at this one, I got a Q on both sides, so that one will close. Here, I don't see anything that's gonna match on both sides. Here, I've got a P on both sides, and then, so that one will close, and then nothing here is going to contradict what. So since we have an open branch, all we need is one open branch, but we've got multiple here. This is gonna be invalid, and we need a counterexample, so I'm just gonna pick this one here on the far left. It's where both of them are false, both P and Q, because they're both on the right-hand side. But if you wanted to, you could also use this one as your counterexample where both of them are true. Okay, so we've got two premises here, and then our conclusion. Gonna move a little bit faster now. So biconditional here on our first premise, so where's a biconditional true? Because it's on the left-hand side. Well, it's where they're both, or where they both match. So either they're both true or they're both false. And then we just need to flip our tilde Q's across. So this tilde Q goes over to the right-hand side. This tilde Q goes on the left-hand side. And then we're done with that premise. Now we need to do our second premise on both of these branches. So where is a wedge statement true? Because it's on the left-hand side. Well, it's where either side is true. So I'll take my tilde P, put it on the left-hand side here, my tilde Q, left-hand side here. Same thing over here. And then I just need to flip these. These tilde P's become regular P's by flipping them across. Same thing with the tilde Q's. And then that premise is done. And then finally, I have a conjunction statement as my conclusion. So conjunction is false because it's on the right-hand side where either side is false. So I'll take my tilde R, put it over here, my tilde Q, put it on the right-hand side here, and then I just have to flip them all across. So all the tilde R's become regular R's and all the tilde Q's become regular Q's, and then we're done. Now we just need to figure out if it's going to be valid or invalid. So I've got a contradiction here up through these branches because I've got a P on the right and a P on the left. So both of these branches will close off. Looking at the next one, this one's gonna be open. I don't see anything. I don't see a P, Q, or R that contradict. Here on this branch, I do have a Q on the left and Q on the right, so that one will close. Looking at this one here, I don't see anything that's going to contradict, so that one's going to be open as well. Looking at this one, no contradiction. Looking at this one, well, I've got a Q on the right and Q on the left, so actually both of these will close because of the same contradiction. So those two will close. Now we just have multiple branches that are open. Again, it just takes one to be invalid, so this is going to be invalid, and then we need our counterexample. So I just picked the one in which P is true, Q is false, and R is true. So R is true, Q is false, P is true. So just going back up through the tree to figure out those values. Another sort of long one here, so I've got my two premises and then my conclusion. So I'll start with my first premise in purple. So I've got to flip it across to get rid of the tilde that's connected to the parentheses here. And so now I've got a biconditional statement. If a biconditional is on the right-hand side, the two sides don't match. So I've got an R on the left, Q on the right, R on the right, Q on the left. Then we're done with that premise. Now we just need to do our Q wedge P. And so again, this is going to be another branching rule. So wherever the Q is true or the P is true, again, it's just the same exact thing over here. And then we're done with that one, and now we just need to do our conclusion. So the main operator here for this conclusion is the arrow. So don't just flip it across for the tilde next to the R, because the tilde is only on the R. So we need to do the arrow rule. So arrow rule, when it's on the right-hand side, means that the left side is true and the right side is false, so it's a stacking rule. We need to flip the R's across, so all the tilde R's become regular R's by just flipping them across. And then we just have to do our conjunction here. So conjunction on the right hand side, meaning that it's false, is wherever one of the sides are false. So we again branch out, so tilde q p. So this is just branching out into this, and then we just have to flip the tilde q's across. So just a reminder, this is all the same exact thing in all these branches, so please don't get overwhelmed. It's just doing the same exact thing 4 times. So now we need to look for contradictions. I've got contradicting q's up here, so actually both of these will close off at the same time. Looking at here, I've got an R on both sides, so both of those will close off at the same time. Looking over here, I don't see anything that's going to be on the left-hand side and the right-hand side. So that one's going to be open. Same thing here. And then looking at these, also open. And then I've got a P on the right and P on the left there, so that one's closed. So since I have an open branch, it's going to be invalid, and then just need to come up with a counterexample. So counterexample, I'll have as P is false, Q is true, and R is false. So this is a interesting case, and I wanted to mention it. So the values here are P is false, R is false, Q is true. But you might think, well, if I go up through this branch, I don't see a P anywhere. How do I know what to put as P as my in my counterexample? If I go up here, because I've got a Q on the left, Q on the left, Q on the left, R on the right, and the what this means here, if a letter does not pop up, it means that the truth value of that propositional statement actually doesn't matter. You could put it as P equals true or P equals false, because in both those combinations it should be invalid. And so that's why if you look over here on this open branch, you have a Q that is true, you have a P that is true, and you have an R that's false. So either combination of P being true or false doesn't really matter. That would be part of the counterexample. You won't encounter this much, or at least I try to make sure you don't encounter it too much, but I just thought you should be aware that sometimes this will happen. Okay, so we've got one premise here, and we've got our conclusion. So starting with our premise, the main operator is the tilde, so we need to flip it across to get rid of that tilde. And then now we have a wedge statement as our main operator, so we need to break it down, and by breaking it down, we're just going to stack both sides on the right-hand side, because a wedge is false where both sides are false. And then we just have our R arrow Q, and arrow on the right-hand side is another stacking rule, because an arrow is false where the left side is true and the right side is false. And then we're done there. Next, we need to move on to our conclusion. The main operator here is the ampersand, not the tilde, because the tilde is only connected to the P. So where is an ampersand false? Well, it's where either side is false. So we'll take our tilde P, we'll put it here. We'll take our tilde Q double arrow R and put it over here. So both on the right-hand side, because they would both be false. Now we need to flip our tilde P across to get regular P. We need to flip our tilde Q double arrow R across to get rid of that tilde. And then we need to break down our double arrow. So biconditional is true, where both sides match. So either they're both true or they're both false. And then we're done, we've broken it down to the simplest letters. So looking at this first branch, I have a contradiction here. I've got a P on both sides. If I look at this branch, I also have another contradiction. I've got Q on the left, Q on the right, so that one will also close. And then I've got a contradiction here where I've got an R on the right and an R on the left, so that one will also close off. So this would be valid. Okay, on this one I thought I would introduce a fourth letter. So we got P, Q, R, and S, just to show you the sort of power of a truth tree over a truth table. So remember, for a truth table, since we have 4 different letters, we would have to have 16 different rows, which might be a lot to try to manage. So truth tree might actually be easier here. So looking at our premise, our arrow is the main connective. So an arrow is true where the left side is false or the right side is true. Now, looking at this P and Q, where is a conjunction false because it's on the right-hand side? Well, it's false where either of the sides are false, so that's why P goes over here, Q goes over here. Then moving on to this wedge. So wedge on the left, where's a wedge true? Well, it's where either side is true, and so that premise is done. Now let's move up to our conclusion. The main operator here is the double arrow. So if a double arrow is on the right-hand side, meaning that it's false, it's where they don't match. So R or S on one side, P on the other, and then just flipped on this one. And it's the same exact thing in all of these different branches. Looking at the R or S when it's on the left-hand side, so if it's true, we got to branch again, and that is where either side is true. So either R is true or S is true, and then all of this is just the same exact thing repeated. Then we have our R or S's on the right-hand sides. So if a disjunction is on the right-hand side, that means both of those have to be false. So R and S just get stacked on the right-hand side in all of these. Now, looking for contradiction in this first one, I don't see one. Same thing here. Well, here I've got a P on the left-hand side, P on the right-hand side, so that one closes off. Don't see a contradiction there. Don't see one there. Don't see one there. Don't see one there. Don't see one there. Oh, got one here. So R on the right, R on the left. Looking at the next one, nope, nope. And then finally, yep, I do have an S on both sides. So this is going to be invalid, and I'm going to base my counterexample off of this one because I have all the different letters. But just like I said before, if you don't have a letter in a branch, then that means that it doesn't really matter if that letter is true or false, but you still do have to include it in the counterexample. But if we pick this one, we have truth values for P, Q, R, and S. So it would be where P is true because it's on the left-hand side, Q is false because it's on the right-hand side, R is false because it's on the right-hand side, and S is false because it's on the right-hand side. We'll revert back to three different letters here. So we have P, Q, and R, and we got our two premises here, the one in purple, one in green, and then we've got our conclusion, which is just P here on the right-hand side. So looking at our first premise, the main operator here is the ampersand. It's holding together this tilde R and the P wedge Q. So we just stack them here on the left-hand side. Then we need to flip our R across to get rid of that tilde. And then we need to branch out for our P wedge Q. So P wedge Q is true where either side is true. And then that premise is done. Next, we need to move on to this premise. So the main operator here is the arrow. It's holding together the tilde R and the tilde Q. So if an arrow is true, then either the left side is false or the right side is true. So tilde R false, tilde Q true, same thing over here. Then we just need to flip our R's across. Then we need to flip our Q's across. Done there. And now we're going to look for contradictions. Oh, I got a P on the left-hand side, P on the right-hand side. So both of those will actually close off at the same time. Looking at this one, I've got an R on the left-hand side, R on the right-hand side. So that one will close off. Here I've got a Q on the right, Q on the left. So that one will close off. So since all the branches close off, this one's valid. All right, another one in which we have two premises and our conclusion. So first premise here with our arrow being our main operator. Again, we just got to break it down where the left side is false and the right side is true. Then we need to flip our P across to get rid of that tilde. And then we're done with the first premise. Second premise, the main operator is an ampersand, so we got to stack them on both of these branches. So where tilde R and Q are both true. And then we just need to flip our R's across to get rid of that tilde. And now we're done with that premise. And then we just have to do our conjunction, which is on the right-hand side. So if it's on the right-hand side, we got to split them up where one of the sides are false. And then we're done with that. And so now let's look for contradictions. I got P on the right, P on the left. So that one will close off. I've got a Q on the right, Q on the left there. So that one will close off. I've got, let's see, an R on both sides here, so those both will close off at the same time. So again, we've got a valid argument. All right, moving on to the next one, we have two premises here and then our conclusion. So looking at our first premise, the main connective is our arrow. So where's an arrow true? It's where the where the left side is false or the right side is true. Don't have to do anything here. Gotta flip this across. So we'll change this into an R and a Q. And then if a conjunction is on the right hand side, we have to split it apart again. So where R is false or Q is false. So that one's done there. Don't have to do anything with our second premise because it's just a single letter. Looking at our conclusion, it's a conjunction on the right hand side. So again, splitting. So tilde R on one side, tilde Q on the other, both of them on the right hand side to signify that they're false. And then we just have to flip all the R's across and flip all the Q's across. And then we're done. And then if we look here, we've got a P on the right hand side, P on the left hand side, so both of those will close off. If we look at this one here, I've got an R on both sides, so that one will close off. Here I don't see anything that's on both sides of the tree. Same thing here. And then I do have Q's on both sides, so that will close off. So this one is also going to be invalid. We'll need a counterexample. So I just picked the one where P is true because it's on the left hand side. Q is true, it's on the left hand side. R is false because it's on the right hand side. Again, we got two premises here. So looking at the first one, the main operators of the double arrow. So where's a double arrow true? It's true where both sides match. So R and P arrow Q are true, or they're both false. Now, looking at this one, where's P arrow Q true? Well, it's where either the left side is false or the right side is true. And then looking over here, where's a P arrow Q false? Well, it's where the P is true and the Q is false, so they'll stack here. So just be careful, if an arrow's on the left-hand side, it branches. If it's on the right-hand side, it stacks. Then looking at our next premise, we've got an arrow as our main operator. So again, we got to branch these out. Wherever the left side is false or the right side is true, all of these are the exact same. Then we just need to flip our Q's across. Then we need to flip our P's across. Done there. And then our conclusion is just a single letter, so don't have to do anything to it. If we look up here, I have these two, or sorry, I've got an R on the left-hand side, I've got an R on the right-hand side there, so all four of those will close off at the same time. Looking over here at the next one, I've got a Q on both sides, so that one will close, and I've got a, looks like a P on both sides, so that will also close there. So since they're all closed, makes this one invalid. Okay, last one, and I figured I'd toss in another case in which you have four different letters. So you got P, Q, R, and S. Again, don't let that scare you. Just do things one statement at a time. So our first statement, our first premise is an arrow. We've been doing a ton of these. So wherever the left side's false or the right side's true. Then we look at our second premise. It's a double arrow. It's wherever they both match. So R and tilde S on both sides, or sorry, both as true or both as false. And then we just have to flip our tilde S's across on each of these branches, and then that one's done. Now we do have a rather long one here, which we have an arrow on the right hand side. So again, these are going to stack because the arrow's on the right hand side. So we're going to take the left side, put it on the left side, take the right side, put it on the right side. Then if we're looking at our conjunction here, S and P, or sorry, tilde S and P, I guess I should say. If it's on the left-hand side, it should stack. So tilde S and P on the left-hand side. So that's why all of these get stacked like that. And then we have an R and Q on the right-hand side. So with a conjunction on the right-hand side, oh, sorry, I have to flip the tilde S first. And then looking at this conjunction, splitting it apart where each side is on its own branch on the right hand side because it could be false. And then if we look up through each of these branches, I have a P on both sides here, so actually that will close both of those off at the same time. Looking here, I got a similar situation, which I got a P on the left-hand side, P on the right-hand side, so all those will close off at the same time. Looking up through here, looks like I have an R on both sides, so that will close that one off. And then this one here, I've got a Q on both sides, so that will close that one off. And then looking here, it looks like I got an S on both sides, so close those two off. So since they're all closed off, makes this valid.